Okay, so good morning, class. All right, sit down. So today we'll be doing an experiment, and this experiment is to see how gas expands when the pressure is kept constant, okay? But before that, we'll just do a little recap on the gas laws that we have. So right now I am in PHET Simulations. This is very good for you to see physics simulations anytime. You can just go online, look for PHET interactive simulations. Okay? So this one will be discovering the gas laws. Okay, so let's wait for it to load. Okay, so we're discovering gas properties. We'll be looking in ideal gases. So what we have over here is a chamber. We can actually open and close the lid, expand it, and we can also heat it up and make it cold. Alright? So let's see. Let's add some particles. How many particles? Let's put light particles. Let's give, I don't know, like maybe about more? More. Okay, enough. Enough. Okay, so now we have all the particles inside here, 300K. That is about like what? How many degrees Celsius is that? So, let me turn off the light so you can see easier. So that's about room temperature, about 27 degrees Celsius. Okay? So now what happens if I heat it up? What do you expect? Will the pressure increase? Or will the volume increase? Okay, right now the pressure is increasing, kan? You can see over there, the pressure meter is increasing. Now let's say if I fix the pressure. What happens when I heat it up? See? So what can you say by this? Okay, if we fix the volume, what happened? The pressure increase, right? It'll increase until and our thing fly away. Okay, let's restart the whole thing. Okay. So now let's put maybe 200 particles inside here. Okay? So if we were to fix the volume, keep the pressure constant. So who wants to try to heat it up or cool it down? Anyone? Okay, Dorothy, come up here. So you can play around with the heat.
Pressure cannot be held constant. Bollywood.
Okay. Now increase. Oh, you need to set the pressure like it. Okay. Now heat it up. So what can you see? This is gas particles. So if your pressure, if you put constant your pressure, what will happen? Huh? The volume will expand, right? So what happens if we, for example, fix the volume? Okay. Now let's try, if we fix the volume and heat it up, what happens? The pressure will increase, right? Okay. What if we cool it down? What happens to the pressure?
It will decrease.
It will decrease. Okay. Let's see what happens. Can you try to cool it down until 0K? Okay, as Dorothy is cooling it down to 0K, remember what I told you about how kinetic particles, the average, we call the temperature the average kinetic energy of a particle. Meaning to say that if these particles slow down, the average kinetic energy will be less, right? And therefore the temperature would decrease. So let's see what happens when we reach somewhere close to 0. See whether they actually stop or not. Because technically, if it's 0 Kelvin, all the particles should freeze.
7,
All right, let's see.
6, 5,
See how much slower it's going?
4,
0.3,
3,
0.2,
2, get it? Oh, it
Okay,
is
it is
slow.
very slow. If we leave it for a while, it will actually stop.
The freeze.
It's very slow now. It's still moving just a little bit. Okay, okay, and
belum. Kat ni. Ayah kat.
Is it freeze?
okay. Let's consider this it stopped already, right? It may be a little bit. It may be moving a little bit, either because it's an optical illusion or yeah, it's not moving anymore.
Yeah, it's not.
Okay, so you see what happened when your temperature is 0, the particles is actually what? It froze, all right? So this means that what temperature is this? What do we call this? This is another name for this 0 Kelvin. We call it? No, we call it absolute 0, which by definition is the coldest temperature that this universe can ever achieve. Yes, because we define our temperature as average kinetic energy, kan? So if average kinetic energy of this particle is 0, because it's not moving. So if it's not moving, there's no average kinetic energy. If there's no average kinetic energy, then the temperature will be 0 Kelvin. So this is actually the lowest temperature that we can ever achieve. So far in laboratories, we have achieved maybe 3 to 4 Kelvin, but we have not yet achieved 0 Kelvin yet. Maybe in the next 20 years, maybe through scientific breakthrough, we will be able to achieve 0 Kelvin. What happens then? We don't know yet. That's why we want to try. All right? Okay, so now let's go to your experiment. I want you guys to turn to page